Okay, so today what we're talking about is parabolas. There is a Common Core standard which I did not look up. I'll look up later. So I want to go back through a couple of little things. On a reading real quick, we learned that the axis of symmetry is a line that goes right through the middle of it. Right down the middle, and it always goes through the vertex. Okay, it will be an x-equal equation. Any line that goes straight up and down is always an x-equal equation. X equals some number. Okay. In this case, it's going to be x equals negative b over 2a. Standard form of a quadratic function is ax squared plus bx plus c. And a, b, and c are just numbers. We're going to see different problems where they have different numbers. We also learned that parabolas can be drawn like a smiley face, and that's if a is positive. This number here is positive, which would give this to be a minimum. And sometimes parabolas can be upside down depending on if this value a, if it's a negative value here, it'll be upside down. I call it a frowny face, which would give us a maximum, okay? Really nice notes I gave you already. This is the parabola in vertex form, which is different, quantity squared, than what we are doing today. There are advantages to both. So if we look at our notes today, let's take a look at what we have. So example 1, from the parabola shown, find the vertex, the line of symmetry, the y-intercept, and the x-intercept. Well, this was pretty easy because we can just see it. So first of all, let's take a look at it. So the vertex is right there. Okay, there's my vertex, and that's at the coordinate 2, 1. Okay, I just found it from the graph. Just located it, right? We know that it's upside down, so whatever the equation is, that a has got to be negative, okay? Less than 0. A, whatever the value is, it's upside down, it would be negative, okay? Next thing we find, pretty easy, are the x-intercepts. X-intercepts. And the x-intercepts are here and here. All right, they are where it crosses the x-axis. It's also where y is equal to 0. It has a height of 0. So this x-intercept is at 1, 0. It has to be 0 because that's the y value would have to be 0, right? That value is 0. And the other x-intercept is at 1, 2, 3, 0. Okay. The y-intercept, that's where it crosses the y-axis. And the y-intercept, let's see, what other color do I have hiding in here that I can use? Here we go. Here's my y-intercept, is right there, and it is at the point 0, negative 4. Alright, pretty easy. All we're doing is identifying things in the parabola. So today's lesson is pretty easy. We're just going to look at parabolas and do the easy stuff. Tomorrow might get a little bit harder, okay? Yes.
Or, I mean, negative 3.
1, 2. Oh, you know what, Nathan? I need to get my glasses fixed. There you go. Thank you. Need better glasses, huh? Thank you. Okay, example 2. So now in example 2, we don't have a graph to find it, but we do know, if we take a look at these cool notes I just gave you, it's in vertex form. See, it's in this exact form here. See the parentheses squared? So if it's in this form, parentheses squared, then it's in vertex form. Well, the vertex is just these two numbers. So if I take a look at this equation, here's my vertex. But it's the opposite. Remember how we talked about that? It's the opposite of the inside number. So my vertex, without seeing a graph of this, without looking at it, the vertex is at 4, negative 4. Okay, it's the opposite. It's negative 4 here, but it's really a positive 4. Okay, so we take the opposite, okay? Now the line of symmetry has to go right through the vertex. Now if I did a really rough sketch of this thing at 4, negative 4, it's got to look something like this. Okay, that's just a real rough sketch of it. And the vertex is at 4, negative 4. Okay, and you don't have to graph this. The vertex 4, negative 4. It always, the line of symmetry is always this number. I'll say it again. Always this number. I'll say it again. The line of symmetry is always this number. Well, it makes sense because if I take a look at it, it's got to go boom, 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 which goes right through the 4. So the line of symmetry is an x equal equation because it goes straight up and down. So my line of symmetry is simply x equals 4, okay? That wasn't too hard. We didn't have to graph it. We just had to come up with two things. The vertex, since it's in vertex form, it's easy. Goes through the vertex. The line of symmetry has to be the x value of the vertex. I'll say it again. Line of symmetry has to be the x value of the vertex. Always. Always, always, always. The x value of the vertex, okay? All right, example 3. Find the vertex and the line of symmetry, okay? Now, it's not in vertex form, which is kind of a bummer because it was so easy when it's in vertex form. I mean, if it's in this nice quantity squared form, the answer is just right there and there, okay? But it's in the standard form. So we learn that we're going to use this formula right here. The vertex is negative b over 2a, all right? So I'm going to use x equals negative b over 2a. It's always nicer when it's in vertex form. I got the answer. This time I actually have to do some work. It's not that hard. B is negative 6 and a is 3 because I've got my a goes with the x squared, b, and then c. A goes with the x squared, b goes with the x, and c is just the number by itself. So to get the vertex, I'm going to go x equals negative 6 because that's my b over my 2 times my 3 because that's my a. All right, negative b over 2a, which makes a positive 6 over 6, which is a 1. Now, a vertex is a point. 1 is only half the answer. I mean, it's a point. The vertex is a point. And what we have is 1 something, right? Okay, we don't know what the y value is, but to get the y value, it's really simple. We're going to plug it in. So we're going to plug x equals 1 into our y equals 3x squared minus our 6x plus our 7. That's how we get it. We got an x value, to get the corresponding y value, you plug it in, Dylan, and you do the math, and you get it, all right? So of y equals 3 times a 1 squared minus a 6 times a 1 plus a 7, right? Let's see, that's going to be a 3 minus 6 plus 7, which is 4, I believe. So my y value is 4, so my vertex is at 1, 4, okay? Even though we didn't even graph it, we know it is, okay? So now, the line of symmetry. Well, line of symmetry is easy. I'll say it again for probably the, what do you think, Abby, for like the 10th time? The line of symmetry is the x value of your vertex. Always. So it's just x equals 1. That's my line of symmetry. It's the x value of your vertex. Line of symmetry. It has to go through it. Now, finally, does this one open up or open down?
Up.
It does. It has to open up because that's a positive, okay? A is positive, right? So it has to open up. So it opens up, which means this has to be a minimum, right? If this value is positive, it opens up, which means it's a smiley face, which means you'd have a minimum, okay? Are you guys ready to turn the page? Easy? Hope so. Right? Okay, example 4. We're going to graph it, okay? Oh, there's the 2a. Finally, I got it right. So from the parabola, x squared minus 2x minus 8, find the vertex, the line of symmetry, the y-intercept, and the x-intercepts, and then graph the parabola. So, all right, lucky you, I gave you these great little notes on how to do all this stuff. That helps. So first of all, let's find the vertex. So the vertex we can find by negative b over 2a. So a is 1, b is negative 2, and c is negative 8, right? So we're going to go, okay, vertex for us is going to be a negative 2, negative b. but b is negative, so negative 2 over 2 times 1. Okay, I'm just using my formula. The 2 is in the formula, so the 2 will always be there, okay? So the 2 is in the formula, so I just went negative b over 2a. So I get 2 over 2, which is 1, right? But again, the vertex is a point. It's a point. So the vertex is going to be 1 something. And to get the something, we just got to plug it back in, all right? So I'm going to go and I'm going to say, all right, what is y is equal to a 1 squared minus a 2 times a 1 minus 8. Let's see, there's 1. My sign minus 8 is a negative 9, so I get a negative 9, okay? So I got a vertex at 1, negative 9. Okay, I'm going to circle that. That's my vertex. Circle that, okay? So I can come back and graph it, okay? That's my vertex. Y-intercept, okay? So y-intercept, if I let x equal 0, I mean, just think about it. This is 0, and this is 0. What's the answer? If this is 0 and this is 0, what's the answer?
0.
With the negative 8 makes a negative 8. So, in fact, even in your cool notes I just gave you, the y-intercept is always 0, whatever that number is, right? So our y-intercept is simply going to be 0, negative 8, right? Now the x-intercept. So to get the x-intercept, let's set y equals 0. So go back up to my original equation, and I'm okay, 0 equals x squared minus 2x minus 8. I got to solve for x. Oh, wow, that looks really hard to solve for x because you got an x squared and you have an x. But we know how to factor, don't we? Factor, we factored this exact one in the warm-up, didn't we? We did. So 2 sets of parentheses, right? X and x. That's right, Elias. How about a negative 4 and a positive 2? Does that make sense? But we're still solving. We still have to solve. So if we're going to solve, then we have a 0 equals an x minus 4. And we have a 0 equals an x plus 2. Well, we're going to get 2 answers. But that makes sense with the parabola. It's going to go through and come back up, right? So I have 2 answers. It really makes a lot of sense to me. So if I go plus 4, I get 1 answer is 4. Or we're going to go 4, 0. Minus 2. So we get x equals negative 2, or an answer of negative 2, 0. Okay? All right, those are my x-intercepts. That 2 answers make sense because the parabola is going to go down through it and come back up. So 2 answers totally make sense to me, okay? Now the line of symmetry, I don't need to do all this work because for the 15th time, all right, the line of symmetry is always the x value of your vertex, right? There it is. So it's just x equals 1 is my line of symmetry. Okay, now we can graph it. All right, let's see. I've got a vertex at 1, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I've got a y-intercept at 0, negative 8. That's right there. I counted down 1, 2, 3, 4, 5, 6, 7, 8, right? I'm going to have an x-intercept at 4, 0. 1, 2, 3, 4. And my other x-intercept at negative 2, 0. Okay. My line of symmetry, which I'll put in a different color because it's not part of the graph. It is just an imaginary line that goes through the middle of it. Okay. There's my x equals 1. And what I really like about this is technically I could put one more point in. I don't need to, but there's one more point right there. Do you see where my pin's pointing? Has to be another point there because it's symmetrical. Does that make sense? So I'm going to put another point there. I know that point's there because it's symmetrical. And I'm just going to draw it in. Now try and draw it kind of curvy. It is not a V. It's a parabola. It has some curvature to it. Okay. There it is. Okay. Questions?